Okay, so let's look at some ransomware. So we'll look at some of the background material around ransomware, and then what we'll do is we'll have a look at the WannaCry malware. Okay, so initially we'll look at some background material and to see if we can understand the basic concepts behind ransomware. One thing that's obvious is there's a great increase in the scope and also in the number of ransomware families that have been uh, developed. And Trend Micro reported recently a 752% increase in ransomware. And it's a highly successful crime, and the opportunities to be caught are fairly minimal, especially as the original source can be hidden within inside within inside the dark web. And we also see that some serious crime gangs are involved. And along with this, we see federal agents going after botnet activity. And these botnets are actually providing the core infrastructure for the distribution and the payment networks that are involved within inside ransomware. Along with this, we're actually seeing a great increase in the number of ransomware families that are being developed. We saw that in 2015 it's fairly flat, but just even at the first half of 2016, there was a general ramp up in the number of ransomware families that were being created on the internet. And then it can be seen it's a fairly successful crime uh, in that 45% of companies paid the ransom and got the data back. 1 in 5 companies actually paid but didn't get the data back. So there's no guarantee that although you pay, you will actually get the money back. And only 35% here didn't actually pay the ransom. So this is a pretty good success rate for a cyber criminal, especially as the chances of being caught are fairly minimal. So let's look at some core fundamental uh, principles and also some families that we'll see. So you can see here after a slow start from GP Coder, we've generally ramped up with the number of ransomware families around. And even in the first quarter of 2016, there was a whole lot of new ransomware families that were being distributed. So here are some examples of ransomware. From 2012, there was this Riviton, which displayed a police message. Went through to serious ransomware in 2014 with CryptoWall, which made their authors 325 million from there. It was one of the first to stay persistent on a machine. Then there was a doxing ransomware in 2015. We then went through with the first JavaScript ransomware in 2016. This one here is the Jigsaw ransomware, which used the characters from the Saw movie and deleted files every 60 minutes, and then another 1K 1000 files on reboot. Went through Locky. Locky targeted healthcare in the US. It was healthcare as a ransom. And we're seeing much more sophisticated ransomware coming through, including, as we've seen, new worms. And the problem that we have is that the source code itself is typically distributed and ported onto GitHub. So in this case, there's a sample ransomware. It's not too difficult for someone to be able to download the code from GitHub and then update as they require. So as vulnerabilities are identified and as systems are patched, then the ransomware family can often evolve. So a cyber criminal doesn't have to start from scratch with the malware code. They can download it from some sort of GitHub repository. So let's look at some ransomware types. So there are 5 main classifications for ransomware. There's ones that lock your computer out. And it's not really preferred these days because obviously the cybercriminal wants you to be able to pay the ransom, so it doesn't do much good to be able to lock the person out of there. There is also typically it's one that involves an encryption key to encrypt and then a decryption key to be able to decrypt the files. We can also have a master boot record ransomware where the computer doesn't boot up until the ransom is actually paid, and the ransomware agent is embedded into the master boot record. Increasingly, we're also seeing web server encryption, where the ransomware can jump onto the web server and encrypt certain key files, and there is a large increase in the number of mobile device ransomware families around. Okay, so one that's been around for a while is the one that shows a picture of law enforcement normally, and it says that you've visited a bad site and that you must pay the the for the crime. So there is normally some payment that you would make in bitcoins and so on. You've been detected in performing a crime, and then you must pay. You'll find that it's customized for the country and the region that you're in. It will have lots of things related to law enforcement, and then to reinforce to the user that this is a serious message. Unfortunately, this type of ransomware has had some serious effects, in that there has been a case of someone who committed suicide because they thought this was a valid message, and that someone would tell their parents about this. Isn't there? Uh, so often you would find the ransomware is around this region here, but obviously if larger companies can be hit, then the fine might be more. But there are certainly some cases that are unreported, but which have actually ended up with values greater than 100,000 for the actual ransom. So the way it typically works is like this, so that you have your criminal. There is a service provider on the dark web normally to provide a console for them to be able to log into, to be able to find their campaign and then collect the money and see how successful they've been. There is then some sort of distributor, typically it's a phishing email type distributor here, and then that's delivered through some sort of vulnerability on the system, through VBS, a document, Java program, and so on. That then creates a unique 128-bit AES key, and then it goes through each of the certain files on the machine and then encrypts them with this key. What would typically happen is that the public key of the command and control system would be used to encrypt this key, this unique key, and then send it back. And then only the private key of the command and control would be able to decrypt it. And then once they've paid the ransom, then this key is then sent to the host and then used to decrypt. But there's no guarantee that even though the money is paid, that the data will be recovered properly. Okay, so normally the executable sits with inside the user app data folder. It creates a registry key to maintain persistence on the machine, and then it will generally encrypt. It will disable shadow copies and make sure there isn't any copies of files stored on the machine. Okay, so some early ransomware, this is one of the first, GP code. It gives you this very basic message here to tell you that your files had been decrypted. They've came a long way since that type of early ransomware. This one here, Reviton, gave you a law enforcement message, but the smart thing about this was that it actually gave you a real-time connection to the operation center to be able to speak to someone, and then to be able to get them to talk you through how you go about decrypting the, the files from the ransomware. And this is very successful because many people will struggle to pay in bitcoins. So in this way, this type of ransomware makes sure that there's a human operator at the other end to talk you through the process. And what we see is that the actual ransomware is then customized for different regions of the world, and where we will see a customized display depending on where you are in the world. So CryptoLocker was one of the most successful, and you received this message here, quite similar to some of the messages that we see now. And basically it used this method of using the public key of the command and control to be able to encrypt the encryption key, which is used for encrypting the file, sending that back, and then the private key on the command and control is then used to decrypt the unique key that's been used. CryptoWall was one of the most successful, and it had a whole infrastructure of support for the crime, from delivery to infection, a whole network infrastructure for payments, and then a whole financial infrastructure for the back end. So CryptoWall 3 allowed a complete infrastructure for crime to happen and gave us the concept of crime as a service. These are some of the files here that have been encrypted. This is the kind of message that you actually get from it, but it actually show in this case that the documents have been encrypted. So as ransomware has evolved, it's moved into what's called ransomware as a service. So in this case, it was identified that there was a tox site, a .onion site on the dark web, which allowed the infrastructure for ransomware to actually exist. A 20% cut was taken for providing the support, so someone could register for this. They would create a console, and then the TOX infrastructure would create the complete infrastructure required for the distribution and maintenance of a ransomware campaign. This is an example of the client for Ransom32. So someone can log in and actually define all the properties and attributes that would be required to be able to create the campaign, and then it then downloads the malware, the ransomware, and then after that it's possible to see how the campaign is actually doing and to check for any payments that have actually been set up. And this was part of what was called Ransom32. So Ransom32 was the first JavaScript ransomware, and it meant that it would affect all types of machines, including Mac OS and Linux. And it basically allowed the code to jump outside the sandbox of the browser and run the vulnerability locally. And it used the Node.js JavaScript to do this. Okay, so here's an example of the console here for Ransom32. So once the user enters these details, such as for Bitcoins, payments, and so on, and then you'll see the Bitcoin address defined here, then downloads this as a zip file, and these are the kind of contents, and there's a fully packaged vulnerability in this case for Ransom32. Okay, if we could look at more detail at what's actually in there, we see there is often a VBS file. That's the little Visual Basic scripting program that runs on the machine that allows the script to happen, for the download to happen, and for the malware to spread. And there's a few other little things, such in this case, there's a chrome.exe, which is a fully packaged JavaScript file that has the code and the framework required so it can be standalone in its operation. And the malware itself will only look to search for certain files, but these are probably key files and for the user. They're images and documents and spreadsheets, Python code. There'll also be things like databases, and the ransomware will probably avoid certain folders like Windows and program data, temp, recycle bin, because that might cause problems in the computer booting up again. So this is the type of code that we see here to be able to run the basic script, and we can actually see that's creating folders uh, and so on. Okay, Locky has arrived fairly soon, and it was targeted in healthcare organizations in the US. It was released around February 2016 and infected the Hollywood Medical Center. It's a fairly high uh, uh, fee that it took, and it was a download of a doc file to be able to infect the the machine. So this is a real life infection here with Locky. So you actually find when the ransomware is running, it really doesn't give a lot of feedback in its operation. So you can see Locky's been run here, and we don't really see that much activity on the machine. But what's actually happening is in the background it's searching for files, and then it will be encrypting them as we're actually watching it here. So if we actually go into the pictures folder, we can see they're now .locky, which means that the files have been encrypted. And we now see this message coming up, and it tells us where we should pay uh, the, the the bitcoins. So it's encrypted with RSA and with 128-bit AES. Okay, so it's 128-bit AES for the encryption, and then it's RSA 2048 for the public and the private key. It's then given us the addresses that we need to go to be able to make the payments. Okay, so that's what our ransomware looks like when it's running. Cerberus was also one that's arrived fairly recently. What was strange about it is that it had a list of countries that it should not target. Everything is run encrypted, so it connects to the Tor network automatically and then will run off of there. It also has text to speech, so that it is possible within the language of the user to be able to speak to the user and explain how they can actually make the payment. Okay, so it was released in 2016, uses UDP traffic. This is what the traffic actually looks like. It scans on a certain network on a certain port 6892, and that's the one way that we can actually detect it from there. It has a number of predefined IP addresses already built into it that it will actually look for. And along with this, we also get what's called the Atom Payload Builder. It's possible to build the payload and then actually define the Bitcoin payment infrastructure as a service. Okay, so now let's look at the Wanna crypter and see if we can actually understand its basic operation.
Now, medical services across
So
England
this
and
was
Scotland will
the
be
kind
disrupted
of
today as work to
message.
restore NHS computer systems continues.
Planned operations and appointments at around 40 trusts have been cancelled after a cyber attack struck the health service yesterday afternoon. We've been hearing some patients' experiences, including this man who had major heart surgery cancelled.
I've been waiting for it for many months now. They only do it on a Friday morning, lunchtime, afternoon-ish. Yeah.
And you expected to have the operation today?
Indeed, yes, yeah. I was all cannulaed up. I daren't show you I've been shaved down the front because they were going to open me up. My arms have been shaved, so I was all ready to go, nil by mouth, since this morning. And then at 1:30, the surgeon turned up and said, unfortunately, we've been hacked and there's nothing we can do. We can't operate on.
Okay, so this was the attack against the NHS, where a number of machines had been compromised with the WannaCrypter ransomware. This was the type of message that was received on the machines, and it was typically around XP type machines, but it could be open to many other types of Windows machines, but it particularly went for XP because XP hadn't been updated against the vulnerability. And this was the actual vulnerability itself. It was released on the 14th of March, and it was defined as critical and related to the Microsoft Server Message Block SMB version 1. And so systems across the world had hopefully been patched for this, and firewalls had been hopefully blocked against any sort of traffic. But this was the way that the malware actually got into a network and how it would actually spread. And it was said that the actual vulnerability came from the NSA and then was actually distributed by shadow brokers. And this was the framework which was actually released around these hacks. So these were well known, or they became well known vulnerabilities. And the one at the top there is Eternal Blue, and this was the one that was used to be able to distribute the WannaCry ransomware. And as part of this framework here, so this framework had a number of vulnerabilities in it, and it was used to be able to compromise network systems. But then it was released, and where Microsoft released a vulnerability assessment for it. So WannaCrypter went live, and we can actually view here a real-time display of infections as they actually happen. So these are all the infections happening in real time. So we can see here quite a few in Europe and the USA, along with quite a few over here. But this is showing the WannaCry ransomware affecting systems in real time. VirusTotal very quickly created a signature for it, and we can actually download the file details. There's still one virus scanner which thinks that this is actually quite a valid, harmless program, but it isn't. So this is the exe here, and this is the report and the names that each of them are actually giving it there. But we can actually go and actually have a look to see the basic details of it, the hash signatures that we're looking for, and then also all the details of the network connections that it makes, and so on. Okay, so often VirusTotal is the place that we would go to be able to understand the malware itself and look for the different types of signatures that it actually has. Okay, so we can actually look in real time for this. And the vulnerability has been so so difficult for many organizations that really Microsoft had to go ahead and actually patch XP systems because there were so many systems running XP. So if anyone remembers XP, then you'll actually find that it's actually running on ATM systems. So in this case, we can see XP running there. At one time, just a couple of years ago, it was quoted that 90% of ATM systems were running Windows XP. This one here shows XP systems running in an airport. The other two are ATMs. And this one is even running Windows 95 for flight arrivals there. This one's also looking at in an airport, and this one here is quite fun where it's actually running solitaire on an ATM system. So with WannaCrypter, then we have various vulnerabilities around some of the ports that it actually uses. So the main port or the main protocol it uses is SMB. So SMB is a protocol which allows files to be shared across a network. It's not really meant for sharing across the internet. It's meant to be a very local share, but it's well known that it's fairly vulnerable to attack because it can be a way of getting into a computer. If we look on Shodan, we actually find that there are quite a lot of machines actually on the internet exposing the SMB protocol. And really, there probably shouldn't be too much because really, the minute we put SMB online, then it can leave us open to attack. We can see there are over 900,000 computers broadcasting or ready to connect to port 906. We can also look at the number of XP machines that are live on the internet and which could be connected to. So in Shodan we look for operating system : Windows space XP, and it should give us some idea about the actual XP machines, and there's 49 there, and we can actually see some of the details of those machines, such as printers connected to them, local disk shares, and so on. Okay, so there's an example showing our SMB there. There's an example of an SMB share, runs off port 445. So if the firewall exposes 445, then it might be possible for somebody to connect to that port remotely. So there was intrusion detection signatures set up, and they focused on detecting on port 445 as the way that the malware propagated. Here's an example here of this machine here, and we can see that SMB is exposed here, and then when we do an nmap on the machine, we can actually see that one of the ports that are open is 445, and this was the port, the protocol port that was used to distribute the malware. So the code itself looks a little bit like that, and one of the files, there's the executable, and then one of the files started with this PK, which is well known to be a zip file. When we analyze the machine code, we actually find that the actual encryption, the password for the zip file is actually encoded into the malware itself. So when you put that password into here, you can actually decrypt the associated files. Then I'll also distribute it with the malware as a file such as this, which gives you the details of the message that gets shown to the to the target. So if we want to look at the actual traffic that it causes, we can take our PCAP file, and one thing that we can see is that it contacts a certain number of IP addresses. So when the exe is running, it contacts a whole lot of Tor nodes to make the connection to distribute the key to the command and control infrastructure. So this is the connections here, and we can see here there's a connection from the local machine to 213.61.66.116, and then it's connecting on port 9003. If we want to create a snort signature, so from that we can find out what the machines we're connecting to on the Tor network and then try and detect them. So this is detecting these 6 addresses, and we'll just try and run that from here. So we can do that by reading in the PCAP file, that's the Wireshark trace, and then we can run the rules in and see what it does. So we just run that through, and hopefully it's created 9 alerts. That's good. And we'll have a look at the log folder, and we'll see what alerts it's came up with, and there it's there. Okay, so it's detected that connection and that one, and then so on. So the operation of WannaCry is this. Initially, it makes a DNS request for these 2 domains that we see up the top. If it finds them, then it kills itself and it stops itself working, which was quite useful because a researcher found out these domains and went ahead and registered them, which meant that the malware stopped working. So it would have been much worse if it hadn't been for this kill operation. Next, if the domain doesn't exist, it then goes ahead and downloads from these 2 places a complete Tor client. So the Tor client will be then used to be able to connect to the dark web to be able to maintain the campaign. It then scans the local network for 445 until it tries to find a machine which is vulnerable, and it'll try and infect that machine. After that, it goes ahead and then tries to scan random addresses across the internet to be able to propagate itself. So in this case, it tries to keep itself alive across the network and keep scanning. The last thing it does is then to go and connect to the Tor network. So these are certain addresses and ports that it connects to, and these map to these types of addresses here. But unfortunately, there's a bug in the system and it doesn't quite work. So the decryption key doesn't work there. So even though you pay the ransom, you might not get your money, you might not get the data back again. Okay, so there are 3 wallets that are associated with WannaCry. These are the 3 here. Recently there was 102, 87 and 78 transactions on each one, which comes to about $80,000 or so. And we can actually look at these in real time. So this is one of the addresses. So the way that Bitcoin works is that we have a wallet which is associated with the three accounts, and then we should be able to see all the transactions. But it's pseudo-anonymized, so that we won't be able to see the full details of who owns the wallet. Hopefully this is going to come through. Okay, so we can look at the transactions there. So these are all the payments that have been made. 0.1 Bitcoin, as we can see, is about $200 there. This is the larger one. So there are two basic levels of payment, from about $300 to about $600 there. So we can see when the payments have been made. So every so often a new ledger is created, but we're actually seeing these payments coming in as a single transaction there. And it's difficult to know where the payments have came from because they're all pseudonymized from them. And generally the transactions started about the 12th of May and then have kept increasing from there. Okay, so in terms of conclusions, basically to be able to overcome this type of attack, then the trend to micro advice is really education is the core of this. Normally this would come in through a spear phishing attack, and not through the method that we have seen of using XP machines and unpatched systems. So it will often be unpatched applications such as Flash, Java, and Adobe Reader that would allow the ransomware to come in. It's important to have backups, and Trend Micro recommend the 3-2-1, 3 copies of a file in 2 different formats such as magnetic and tape, and then 1 copy off-site or offline. And then there's another one around layered protection to make sure that the network has many different layers of protection. When it's under attack, we can add in new layers. Then to go for network segmentation, to segment the network up into small segments so that they can be isolated and don't affect each other. And then finally to look at application control and to look more for a whitelisting policy where you actually define what's allowed rather than a blacklisting one. And then, are we changing ransomware? Traditional one is to come in through a phishing email, to then look at some sort of vulnerability through Adobe Reader, Flash, Microsoft Silverlight, Java on unpatched systems, then using a proper command and control to be able to deliver the payload and decrypt, and then with Tor Bitcoin integration. WannaCry was more of a worm. It distributed the full payload inside the distribution itself, and then was available through a network share. Okay, so that's we've got to be seen, but it's likely that we'll go back to a more traditional type of ransomware attack. And that's been a quick overview of ransomware.